So this comment was posted on a video by someone who claimed to have a PhD and said that scientists don't know why water boils, specifically the bubbles. Anyway, don't worry about it, it's a troll account. I mean, A, stitches and duets are totally turned off, and he doesn't let any of his videos get downloaded for people to respond to them. B, he called Hank Green a charlatan. C, in one of his responses, he said that water boils only due to heat. And in response to people who mention atmospheric pressure, he said that putting water in a vacuum generates heat and that makes it boil. And pretty easy thermodynamics 101 should tell you that heat does not transfer easily in a vacuum. Thermoses are made using vacuums. There's a bunch of nothing between the metal walls of a thermos. That's why it holds in heat very well. And, perhaps like an idiot, I double and triple checked just to make sure that there wasn't something very, very, very complex happening in boiling that we don't yet understand. Because, that's the case in a lot of science. Simple things that it seems like we totally understand have some areas of them that are still unexplored. Anyway, after doing research, I couldn't find anything that says we don't know why things boil. It is what it appears to be. It's a rapid vaporization of a liquid into a gas. The gaseous form of that liquid is trapped underneath the liquid itself, which is held on top of it due to atmospheric pressure. The gaseous bubbles rise. The water boils. Anyway, you know what I did find in my research? This awesome clip of Mr. Wizard teaching the properties of boiling to kids. Remember Mr. Wizard? I loved Mr. Wizard. Anyway, I'm going to let Mr. Wizard do the talking. He's much cooler than me.
Think about this. When you boil water, you are adding energy from the stove into the liquid, and you're changing it into a gas, and the gas is bubbling up. See all the bubbles?
Yeah.
And the molecules are flying off into the air. But air is pushing down on top of it. Right?
Okay, yeah.
At normal atmospheric pressure, there's a lot of air pushing down on it. But if you take away some of those air molecules, then it doesn't take as much energy to make the water change from a liquid to a gas, right?
Right. Okay.
So the temperature would go lower.
Right.
In fact, when you get way up on top of a mountain, it would get much, much less than 100 degrees.